All right, everyone. Welcome to the May 13th edition of the Falco Community Call. This is being recorded, so if you don't want to be recorded, please drop off. And it's also subject to the code of conduct that we all follow for Falco community events. I guess we'll start it out with the highlights. Oh, well, we just lost Nova, but do other people want to talk about this highlights number 2, this team proposal? Oh, this is another one. Okay, Chris is back. Chris, we go directly to you per the agenda.
Sorry, I was like, well, I better go get a cucumber Gatorade because we're going to be here for an hour.
All right, do you want to talk about PDIG briefly?
Yeah, okay, so I have an update on PDIG, and then that goes into another project that is right below called Falco Trace. I would like to kind of give an update of what I was able to do with it, and I think Greg on the Sysdig side is also on the call, so he can talk more about the code itself, how it works. I think he used the language, how slow is this thing, later on in the README. And I can talk about a higher level tool called Falco Trace that glues this together with other use cases. And we have it working in Kubernetes and in ECS Fargate. This is a pretty exciting move for the Falco project because this user experience is, you do not have to concern yourself with a kernel module or BPF probe whatsoever. You can literally kubectl run this new image, and you can get Falco running against a single process in Kubernetes right out of the box. No kernel module, no kernel headers, no eBPF probe. It just runs as an unprivileged container, which is pretty slick and would solve a lot of our maintenance problems as maintainers of this. And PDIG enables this new higher level tool. So Greg, if you're here and you want to maybe give us like a quick rundown of where we're at with this, I think that would be helpful.
Yeah. So, well, unfortunately, I need to cut down on this enthusiasm a little bit, as it's not as you cannot use a totally unprivileged container for this. You need the sysp trace capability, and this has been enabled on Fargate only recently. And this is something that does not come with containers out of the box, but it's definitely an easier thing to get than loading a custom kernel module or even an eBPF probe. So we are not quite there yet for just totally unprivileged instrumentation, and I don't think that's gonna really happen. But this is as close as we can get right now. So, yeah. So the way this works is we are simply using ptrace, so whenever you run strice on your program, this is the exact same thing. So every time a system call happens, your process gets stopped and the tracer gets woken up, and then it can do something. So in the case of, for example, a strice, it just prints out this is called to standard output. GDB just gives you a shell where you can do things. With PDIG, what happens is an event is synthesized and sent to a shared memory buffer where Falco or Sysdig or any other SCAP consumer can read it. So, so the basic architecture is the same as with the kernel module or a BPF probe, where we have a ring buffer of events, and you have a producer side that's in user space in this case, and the consumer side, which is in the Falco or Sysdig process. Yeah, so that's how it works in a nutshell. Well, I said it's just using ptrace. It's mostly true, but not. Well, it's not the whole story. So if we used only ptrace, this would be well, even slower than it is now. So right now we are also using seccomp to add a filter to the process, and that means we are not trapping the target process on every syscall. We are trapping the process on only the system calls that we're interested in. So
which ones are those? I thought with setcomp it was very, very limited set of system calls.
Yeah, well, right now we are in the process of tweaking and fixing this filter. Yeah, so well, when we track this all this down and this works the way we want, the set of system calls will probably change a little bit. But what's not going to change is that we can target syscalls individually. So, for example, we can instrument all open read and write calls and ignore fstat or get time of day. Well, this gives us a nice performance boost compared to just strace without any filtering. So yeah, like in this README, we have some basic benchmarks against OS bench against no instrumentation, and this in this benchmark the worst case is about a quarter of the performance. With full ptrace without any seccomp filters, it was 2 or 3 times worse. Well, of course, this also depends very heavily on the particular workload, but OS bench is, well, let's say it's kind of representative for the memory heavy, IO heavy, and so on workloads. So, I mean, without any explicit kernel support, I think this is as fast as we can get, and also, well, also without any support in the target process itself, because LD preload and stuff would help performance, but also this kind of defeats the point of tracing security. I mean, so you know, if you just want to do something that's not traced, well, just don't call the instrumentation. That's so we need a reliable way to catch all the syscalls, and in this case, I think this is as fast as we can go. So right now, what we need to do is we definitely need to tweak the filter so that we catch all the interesting events and we drop all the events that we are not interested in. Yeah, so I guess you want me to go through the code. Right now, it's not as nice as I'd like it to be.
I mean, I think
you don't have to. I was just clicking around.
Okay, sure.
Yep. I think more importantly on this call, it's going to be more about the fact that this is now a Falco security repo, and making sure that everyone understands that questions and work around this can happen in the open source Falco Slack. And if there's issues or questions or comments, there's the issue tracker, and that this is now following the same processes that we put in place for the other repositories that have been contributed to the Falco security org.
Yeah, yep. I created already the setup for Poiana. When Grzeg wants, I can just click the button and enable it, so to stop the drama with Poiana. So as soon as you're ready, just let me know.
Yeah, right now, well, this code is mostly proof of concept. So well, I think it's not really well great as a showcase of a well designed, well implemented, well polished piece of software. But yeah, we can get there. Well, I guess Poiana is this bot that annoys me whenever I interact with the Falco GitHub. So
yes.
Yeah. So whenever you want, enable this, I'll handle it.
Yeah.
Awesome.
Poiana was annoying to me at first until I started using it for to protect my code, and then I fell in love with it. Okay.
Awesome. Thanks for sharing.
So now that we have PDIG in a prototype state, I wanted to start looking at higher level use cases and building out a framework for getting all of this working with Falco in an easy to use and easy to consume way, with a couple of working examples. So a lot of that work is in Falco Trace. If you go into bin and there's go to build, you can see this is where all what I would call the problems are hidden. There's two to-dos there for myself, where we're basically just pulling Falco from a random branch that has yet to be merged into master. And if you go to the the sysdig code, it's also not from master, but that's checked in as a Git submodule in the root of the repository. So both of those are pointing to branches of the code that contain the udig and the scap changes and the things that pdig needs to compile. All of this gets wrapped up into a Docker file. So we now are given a container image built on Debian that contains a compiled copy of pdig, a compiled copy of the Falco user space component running with -u, and a handful of other small dependencies. And we can use that Docker file as sort of a base to build other applications. So at the top, if you go into example apps, you can see there is a few, the vulnerable server is probably the most interesting. It just does a simple incat reverse shell. And if we want, this kind of demonstrates how a user could run a program with pdig. If you look at the Docker file, you'll notice there's 3 arguments to the command, pdig -a, and then it runs a bash script. And that bash script is what actually goes through and does all of the starting Falco and running the web server. So the paradigm here would be, as long as you write your application bootstrapping logic, it starts from that bash script, it should all be running with the same ptrace that pdig is using. And I've tested it pretty extensively, and that seems to be the case. Spencer, if I can share my screen for a quick minute, I can show an example of this in Fargate. If that's okay.
Please. Yeah, please.
Yep. Okay, so I'm going to go here, share my screen. So without giving everyone here a lesson on AWS Fargate, hold on, let me log in here. I can kind of just show the basics and talk about the system capability that Greg mentioned earlier about how this does require some privileges, which Amazon just enabled. They call it a Linux capability, and you have to define that in the raw JSON of your task definition. So I've created a cluster called NovaHacks. I created a task definition that's using this vulnerable server Docker file that just does the incat. And this is running here. The task is basically like the equivalent of a pod in Kubernetes, and it gets a public IP address. And if I go back here, I can incat into it. Incat is speed pipes to bin bash, so it's just a reverse shell. I can do something malicious here. And if we go back to the AWS dashboard in the logs, because of the way Falco is running with pdig, you can click here in the logs, and you can actually see just now at 8:17, I've got the IP address of me. This is one of my static IPs. Please don't dox me. But the IP of the person who's attaching to the container, and we get a Falco log here, warning sensitive file open for reading, and this is just a standard Falco alert. And all of this is being enabled in ECS, which traditionally has not given you this level of visibility into the kernel. So the beauty of this approach is because the Falco errors are going to standard out, the parlance in ECS is that they're just picked up as CloudWatch logs. So now that we're getting Falco alerts as CloudWatch logs, and we can go into CloudWatch and set up alarms, events, we can detect trends in our logs, and we can start plugging it into other parts of AWS as well. So the long story short here is, if you want to run the prototype code, which we're very clearly advertising is not production ready, and you want to try to run it with an arbitrary application, here's some examples of things that I've been able to do to get this working. and feel free to come through and copy over the application skeleton, make your own, run an Nginx server, run an S3 connector, a static web page, maybe a small API server, whatever you want to do. But you should be able to look at securing this with ECS and Falco. And it doesn't stop at ECS, right? Like I showed the team earlier, if we close this, this is the Kubernetes cluster that we use for Poyana that we were just talking about. And if I get kgit pods, you can see here we have Falco running with no application. But if we want to do Falco with that same image that we were running in Fargate, I could do a krun. We'll call it Falco server -- image Chris Nova Falco trace vulnerable server. And we can now get the logs on Falco server like this. And you can see here, we have Falco starting, loading with PDIG. You can see Netcat is starting, it's listening on port 443. And then, ironically enough, Falco actually alerts against this vulnerable Netcat server right away. So now we have this running in Kubernetes. And if we wanted to open up this port, hook it up to a load balancer, hook it up to Ingress, whatever we want to do, we can now run these containers in Kubernetes as well. So this is the toolbox for people to prototype with if they're excited to get started. And I would like to do what Greg did and propose donating this to Falco Security as well, if that works for everyone else. I can maybe open up an issue and give it a couple days before we make any changes.
Okay for me. Yes, open an issue and let's discuss it.
All right, perfect.
Rad. Okay. Anything else on Falco Trace? That's a really cool utility, Chris.
No. Just, if you have questions, if you want to play with it, go for it. I do not in any way support or endorse the idea of running these containers in production.
Nice. Okay. Let me share again the community call agenda. All right. Then the third one is for everybody. We finally wrote down the SOA of current Falco artifacts and the future plan. There's a bunch of PRs in this direction. Who wants to start talking about this one? Leo?
Yeah, okay. Well, 10 days ago, Chris opened a PR about a proposal about the state of art and the future for the artifacts that we officially support as Falco maintainers. And after very long discussions about names, pizza, and pineapples, we reached out a consensus about the names and the things that we want to officially support. We also create a process for community things, repository things, incubated things, and officially supported things in the Falco Security Organization. And it's all written down here in 2 files. One file represents the current state of art of what we have now. So the deb, the RPM, the tarball, and the Docker image that we have now. And the other file represents the future plans about the packages, the Docker images, and so on. So anyone that has ideas, concerns, and things can open issues, PRs against this, and discuss them.
Okay.
All right.
A lot of work about the refactoring needed for the upcoming release next week has already been done. I think that Leo Grasso will talk about it later. Okay.
I will talk about it later.
So this was just an heads up to let the community know that in those 2 files, you can read about the Falco artifacts.
So now that this is merged, we have plans to take action to make this state of the world, to effectively reconcile this state of the world in the Falco project, correct?
Yep.
Okay.
Right. Okay. Anything else on this? It's very exciting that there's clear direction at this point, and we can keep going. Go ahead.
Yeah, I will talk about this later, but if you want, I can talk now. Laura, Leo, what do you prefer? Because
We're already here. Let's just talk now.
Yeah.
Okay.
Talk about
Okay. Okay. Thank you. So basically, I want just to give you an update about what is done, and what will be done very soon. The first thing is that we moved the example directory and the integration directory to contrib. Those two PR are already merged. And of course, those files, actually, this is not merged, but I think it will be merged soon. And of course, those files are already on the contrib repo as per the proposal. Another thing, we removed the minimal image. This PR is already merged, but actually we are just in the process of renaming it. It will be not really removed. Indeed, the minimal image and the slim will be replaced with a new image called Falco node driver. That if you can open the proposal, the link is not
yeah,
this.
that one, the proposal.
Is this?
As per proposal.
Oh, sorry, my tree style tabs
No
is making
problem.
it difficult.
No problem.
This one?
I put a link in the MarkMD with the right.
It's this 19.
Above. It's above. Yeah, it's above. Above. Yeah.
Oh,
perfect. Thank you.
Sorry.
No problem. Okay. Basically, this shows how the new image names will be. The stable image that's Falco security / Falco will be unchanged. Basically, is exactly as now. This image embeds the Falco driver loader and need to be run as privileged as now. There will be another separated image called the Falco security / Falco driver loader tag. That's basically it's like the previous image, but with Falco driver loader as entry point. Why we need this? Because this can be used as init container. In this way, we can create a deployment where the Falco driver loader image is privileged and run just for a short time, and then the normal container can run without the privileged flag. And for doing this, we need another image that's called Falco security / Falco node driver that basically contains just Falco user space without any driver. And this image is based on the current minimal and is very, very small sized. The other two images as they are now, basically Falco tester and Falco builder, they are used mainly in the CI to build everything. One thing that we want to add, and also that maybe we will add some aliases to those images to make the usage more clear. Another important thing that we will do is to document inside the Docker file and the website the command usage of these images. I think I said everything about this. Okay.
That's tight.
Yeah.
Sweet. Cool.
There is another point in the agenda that's basically related. Some other improvements we are doing on the Falco driver loader. Basically, we break apart the logic of this script in several pieces. In this way, for example, a user can just use the Falco driver loader script only with the compilation or only with the download mode. Basically, these two modes are with -- compile. It try to compile the driver locally. With -- download, it tries to download a pre-built driver. Without any option, it runs as now and will try to do everything possible to install the driver. Last but not least, I'm adding also some regression tests on this script. And I think that's it.
Tight. Thank you. That's awesome. I will say that the little echo star gives me the heebie-jeebies, but it's awesome to have the.
I know. Yeah. One thing I did is that all message that start with the asterisk are just info message.
Yeah.
In this way, we can differentiate the info message from errors or other program outputs.
Yeah, something from like DKMS or something. Yeah.
Yeah, exactly.
Cool.
I hope this will help when debugging.
Awesome. All right. So going back up to the top, we have the update on the Falco profile. Is that Laura and Leo?
Laura, do you want to go? There's Laura here. Okay, I'll go. Basically, recently, in the past 2 weeks, 10 days, correct me if I remember wrong, Laura, we, both of us, have been working on this internal low overhead Falco profiler, which uses basically calls RDTSG through assembly to be a low overhead. The goal of this is, as Lorenzo proposed in an issue that's not linked here, but I can insert the link right now in the document. Just give me a second. It's issue number. Lorenzo opening it tomorrow morning.
I'll add it to the document layout.
Okay, thank you, Chris. Basically, we need a way, since we are through a big process of, we are going towards Falco 1.0. To go there, to be there, we need to have tooling, internal tooling, for example, to study the dynamic behavior of Falco, being more effective while debugging the issues about performances, or memory or other things like that. And so we started creating a tool, which is the Falco Profiler. And the goal is to have a tool that users can enable at runtime at some point in the time during the Falco execution, and then obtain a file that for now we called fpro, just flipping some letters in the name, in the profiler name. And with that file, I put a screenshot here of we use the flat buffers to represent the structure of the codes of tree contained in the profiler. Users will be able to, for example, print out flame graphs and put them into issues, and we will be able to better understand where the problem resides into the Falco execution, and then maybe go, for example, optimizing the rule engine and other things like that. This will also help us with the C API. And it's not a one-day work, clearly. We are working on it really hardly recently, but this was just an heads up that we've been able to reach a status where it works, where it creates the parents tree in the code stack, and we are able to convert it to that file through flat buffers. Next steps that we will work on during next weeks are creating a system to enable and disable it at runtime. And basically we have then to perform some other tests about multi-threading. But that's it. Lorenzo, if you want to add something, please do. Maybe I forgot.
Yeah, it's important now that everyone reads this document and add consensus ideas here, because we are looking this only from our own point of view, and maybe there are some use cases that are not considered yet. So feel free to add those kind of comments or whatever. If you want to get involved in the development, whatever is good. We have some proof of concept code over there, but it's basically, proof of concept code.
Is there an example of how to use this or run this anywhere?
Yes, there are tests for now. If Spencer clicks on the compare tab in GitHub here, maybe we can look at some tests and go scroll down a little bit. If you go to the tests, you can see basically how it will be present in the Falco code base. And
search for expect, Spencer.
Again, this is okay. For example, this is the tree I was talking about. Basically, we created a tree structure with flat buffers that then gets serialized into that binary file, that binary format. To be complete, it could also be outputted in JSON if we want in the future, but I think that we prefer binary for now for performances for various reasons. And what we miss now and what we are going to work is that the process of enabling it with sysctl, with something like that at runtime.
If Spencer scrolls up a bit, we can see how search for profile me.
Yeah, uppercase.
All uppercase altogether. Okay, profile me. Yes.
Yep.
So this is an example function that's been profiled. This function has been probably called by some other function, and it will also probably call other functions. When you enable this profiler, it basically, takes all those profile me breakpoints and takes the enter and the exit time on the function and sends everything to that data structure that Lee was talking about, which takes in account all the steps from parent and child and takes in account the time, and that gets dumped to the binary format that then can be converted to a flame graph or to something else. And this is supposed to be something that you can enable and disable at runtime, and should be very low overhead so that we can enable it in production environments and add more information to the issues that we open. One of the specific examples is the drops. If we will have this while we debug the drops issues, we can understand why the syscall buffer is getting filled because we have a trace of what's going on.
Yeah, what we can do, for example, on the rule side to optimize the engine, because in C++, simply looping on a vector or looping on an array is different. Maybe you have to increment the counter inside the loop or do the loop other way, and that can change drastically the performances. And so this will help us a lot on that. Otherwise, we are blind. We have to just try optimize every function that comes in a huge code base. So.
Well, yes, this injects some assembly in the.
Yeah.
Nice. So we'll be able to measure pretty much any part of the code base that Falco is consuming before and after a given method is executed, and get deep profiling metrics around them, it sounds like.
Yeah. The difference from this between, like, you could say we could run Valgrind against Falco. Yes, that's an option. But that profiles everything, every single, code path that you have. And it does that in, another way, which is from the outside by, basically stopping every, single line of assembly and inspecting it and, going through, which is, not performant in production. So the key here is that we add the profile me instruction not everywhere, but where we feel it's sensitive. And the other thing is that we, make it enable for, a time frame. And it's completely, runtime enabled. So it's not something that you need. Is like with Valgrind, you will need to have a Valgrind install with all of its dependencies. With this thing, you just, say Falco A profile, Falco stop profiling.
Yeah, you run maybe Falco on your Kubernetes cluster. At some point in time, you notice something. Maybe the drop rate starts to increase, and you don't know why. You have no way to debug it. you can just enable the debug at runtime without stopping the container, and then send us the fprofile file.
We had some users reporting memory leaks in the past.
Yeah.
While this is not specifically, created for memory leaks, it could be useful for those. But when we had those issues, like we had like 2 or 3 of them, and it was very painful from a maintainer's point of view, because you have to go and connect. I mean, if you find the right user, they give you SSH access to their boxes, and you can, valgrind the stuff, or you can ask them to do it. But it's a lengthy process. It takes months to solve a bug. While in this case, the user will just upload a file to GitHub after,
So yeah, in that, I will admit that this is a bit above me, but it seems rad. You do have a claim here that there's no identifiable information in these captures, likely. You're pretty confident on that?
To embed any identifiable information in the captures, yes.
Okay.
So ideally, what you see in there is just the name of the file, the name of the function, and the line and the execution time.
Yeah, the number of cycles that execution took.
But not like the workload that the program is working with, so it's not...
No, nothing like that. The only thing that we probably cannot follow this principle for is when we will be profiling the rules, we will at least need the rule name.
Yeah.
Because we need to, to tell the person, hey, this is this rule that is being slow.
But it sounds like you all are imagining a workflow where we just ask the users to just throw them anywhere on the public internet and link them in GitHub, not private. This is how you send it to the maintainers, and the maintainers.
It depends on the specific situation. If you are reporting a security issue, you're going to probably use our security.
Well, even if it's not a security issue, like here's my, when my Firefox crashes, it sends it to Mozilla, but it doesn't put it on GitHub, right? It goes just to the people who should have that information.
So I'm wondering.
I agree with you. Yes, I understand what you're saying. It's probably, the problem is I don't want to put that information in the public. We can think about that. We can, have a place where you just upload the stuff instead. It's totally good. And maybe, have a reference number that everyone can look up.
Yeah, it might end up being a little bit of infrastructure, but it might be worth it. What were you going to say, Chris? Sorry.
I was going to say, I think we're at the point as an open source project where the maintainers themselves are starting to have more and more responsibilities outside of just the normal community and the normal contribution users to Falco. And so the 2 things that came to mind here are pretty much what you said, Spencer, with let's figure out how we want to even advertise the workflow from a user perspective here. But more importantly, this led me down this path of the CNCF is not effectively making us, but strongly encouraging us to move to a CNCF enterprise Slack, which means that we are now going to be bound by the CNCF privacy policy. So I think we're at the point where the maintainers should probably break off and have a call to discuss things like profiling metrics, how we handle what could be potentially considered sensitive information, whether or not it contains anything malicious or unveiling, or if it's anonymous or not, just a place where the maintainers can sort of have discussions about how the project is ran and manage potentially secure information. If you look at the experience when Leo and Lore contributed to Linux, they worked very closely with the maintainers, and it was a very guarded conversation. As a security tool, I think that's going to start popping up more and more for us here. So maybe we should get something on the schedule in the next few weeks for the maintainers, just to kind of have a conversation on what we want to do.
Yeah, maybe. Yeah, Chris, I agree. Maybe we can about this topic, we can build up on what we already have for the security policy, and create another policy for other kind of private disclosures. At the moment, a user, when tries to open an issue, has the opportunity to click View Policy, Security Policy, click the button, and the user has an email to contact us. By the way, an email that's still at sysdig.com, so we should have at falco.com, at least at falco.org. But yes, I completely agree with what you say.
Okay. And one of the reasons I want to bring this up is because we do have the we have the CNCF Slack when that issue is solved and resolved. We have the CNCF mailing list, but part of the CNCF's privacy policy is that at any point in time, those conversations may be captured, recorded, like these video calls are recorded automatically, for instance, which is great for these types of engagements, but might not be the best move for somebody sending over very detailed information about their infrastructure to the maintainers. So at some point, we're going to have to figure out a way to have secure conversations, period.
There's just an addition. When you send an email to the Falco maintainers via the mailing list, it should go only to the Falco maintainers, right?
Yes.
So we can reply to the person, but no one else sees it. So, we could use that medium for those kind of conversations.
We can, but we need to make sure that people understand that that email list could potentially be read by non-Falco maintainers.
Oh, okay, understood. That's the point of the Slack channel too.
And even with Slack, that's the case. So with the new Slack, I think we should treat all private messages, DMs, under that same privacy policy of it potentially could be consumed by the CNCF.
I think that the key of the conversation here is that the person sending the thing, the report or whatever it is giving trust to a specific group of people, which are the Falco maintainers, and not to the CNCF as a broad entity. So Absolutely. The problem is if you send an email and you expect it to be read only by 10 people, then it goes to a broader group of people. It's not good. That's it.
Honestly, I think if we have the maintainers call, the first thing I would bring up is everybody needs a PGP key, period. And then it just doesn't even matter. And then send an email to Lore, PGP sign it, and we're done. We could put that on GitHub.
I already have it, so I don't have to work more for this.
Yeah. But yeah, as a security project, we just need to spend some time as maintainers documenting this and making sure that we're...
Can we switch to the CNCF Slack and just PGP chat messages?
Yeah. Okay. We have 15 minutes left.
Yeah, we actually have 15 minutes left, and the agenda, I think, is complete.
Yeah, it's complete.
Wow.
The profile is very good. It's very powerful, and I think it's going to help solve a lot of problems. I like it a lot. Very good work.
That's all.
Yeah, that's rad. That's super hot. Well, is there anything else anybody wants to bring up?
No, I honestly, I have a crazy day today. I have meetings that are back to back all day long. So if I can get 15 minutes, I'll take it.
Great. Look, everybody, thanks so much. Well, who wants to MC the next call?
I run it.
Okay, you can put me down there too as somebody to help.
Thank you, Chris.
Again, at this point, like it kind of is. It's nice to have an MC, but I feel like everybody kind of pulls their weight at the last minute every week, which seems to be working pretty well for us.
Yes, thanks to whoever created this document, because I was not here 20 minutes before the call. Thank you.
Spencer, thank you for.
Thank you, Spencer.
All right, everybody. Thanks so much. Have a great rest of your day. Bye.
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 Bye, everyone.
Bye.